And I hope you had a slightly shorter coffee break, but it was still good, I hope, with something nice to eat and drink. But now we start the final session of today, and we have a panel here of three speakers, and we will first have three presentations, and then I will invite two more persons to the panel, and we will have a panel discussion where I also, you have the great opportunity to ask questions to these distinguished speakers and panelists. So take the opportunity and think about it while they are giving their talks now, so you are prepared for this. The topic is cloud computing and what it means for researchers as a tool in computing. And we begin with Andreas Staert from Netherlands and SURF. And I think you can introduce what you are doing by giving your speech. So get started, please.
Thanks, Per. Good afternoon, everybody. It's great to be here. My name is Andreas Staert. I work for SURFnet, which is the National Research and Education Network in the Netherlands, comparable to Uninet here in Norway. And I coordinate the cloud efforts over there. I also work for GÉANT, which is the European Collaboration Organization, and I lead our cloud activities over there. So I'm going to tell you about clouds, how we want to bring cloud services to research and education. I can tell you about it from both a national perspective in the Netherlands and from a European perspective. Before we dive into the cloud world, where do I put my... like this. Thanks. Let's look at users first. I want to focus on users. I think users are really driving forward IT now. They bring all kinds of different devices. Look at what we have here on the table. And they are online all the time. They bring their own devices and they want to choose their own services. 30% of the world population is online. In Europe, it's 70%. And do you know what it is for the Nordic countries? Anybody thinks it's more than 90%? More than 95, anyone? It is. It's 97% of you guys is online in the Nordic countries. That's a staggering number, right? And what we do all the time, look at what happens at the internet in 1 minute. 2 million Google search queries, 700,000 objects shared on Facebook, 50,000 apps downloaded at Apple. Wow. And data is growing really fast, 50 times over in the next 8 years. So that is a real big data explosion. And a good thing for us, look at that. IT experts only growing 1.5. So that's a good future for us. But these present challenges to us. The user demands, services, devices, the growth of data, and lots of countries in Europe need to save costs as well, and we want to reduce energy consumption. Can the cloud help? Well, not this cloud. It seems that each vendor puts the name cloud on the products nowadays. I found this one in my local electronics store. Okay, this is not clouds, right? This is not clouds. This is, I think these are very good end user examples of usable cloud services. Who of you guys uses a thing like Dropbox or SkyDrive or Google Drive on a, and okay, that's a lot. And who uses it for work-related purposes also? Don't be shy. Well, yeah, me too, me too. I think that is real cloud. Many people, IT experts, call this shadow IT because we can't control it. But I think for users, this is real IT. And the cloud helps them. Users are choosers, users are driving this. A very compact definition, I think, for cloud services is consuming ready-to-use services from external providers and paying only for what you use. It's not about how it is produced, it's about what you can use, and you want to use it now. You can also look at clouds from a vendor perspective, and I think the distribution chain has really changed because of clouds. In the old days, when you wanted to produce software, you wrote your software to get it to users, you had to print CD-ROMs, ship them, resellers, partners, shops, universities and research organizations buy these products, install it on their own servers, and then users can use it. That's quite a complex supply chain. With clouds, it's much easier. Software company writes the software, puts it on servers, the internet, and we're there. So the cloud is really crushing the middlemen in there currently. really big changes, profound changes. Cloud is disruptive. So the cloud is really good for fast delivery, pay-per-use model, elastic, you only pay for what you use. But of course, and we know this, you store something very valuable outside of your own organization, your data. And can you trust these providers? And trust and control are the main questions surrounding cloud. And in GÉANT, or European Collaborative Organization, we want to help research and education to bring cloud to research and education with the right conditions of use. And that is what we are doing. We need this. We are different than commercial organizations, which are much more silo-based. Look at here, how we are here today. Many different organizations collaborating, the need to share information. So we need data portability and we need interoperability. So to do this, we need standards, both on the technical and on the legal level. And we work on this in our GÉANT cloud activity. I think our network is a very good example. We've been able to build a very substantial and fast network connecting all Europe, and we are able to share information. And we want to do the same thing for clouds. We want to be able to share and connect the clouds together, and we want to connect large cloud providers to this network. To me, the multi-vendor aspect is very important with clouds. The opportunity you have to choose multiple services. This conference says there is not one true path, and that is certainly true for cloud services. With cloud, you have the ability to choose what you want, both from commercial vendors and from providers from within our community. Two very good examples. Sunet made a deal with Box, the file storage provider. Now Uninet starts using this, and we want to scale this up, and we will scale this up through GÉANT to make it available to more European countries, this type of service. Vangelis will tell us about Okeanos, infrastructure as a service in Greece, currently only available in Greece, but we want to scale this up to make that infrastructure available to all of Europe, to all of you. These are two good examples of how we want to collaborate. I can recommend this article as well. It's about the University of Washington, Terry Gray. He wrote a great piece, he called it A Tale of Two Clouds, and he describes why the University of Washington is adopting a multi-vendor strategy. And he focuses on Google and Microsoft as a good example how to prevent a vendor lock-in. Get out of the business where you choose one service provider or one vendor and are stuck with it for 5, 6, 7, maybe 10 years. You can use both, so it prevents vendor lock-in. And to be able to do this, to make great deals, we must collaborate on vendor management and cloud brokerage. And that is what we will do. To bring the costs down and to deal with things like data portability, interoperability. You might know this, but in Europe, if we combine our community together, we are with 50 million users. And I think the size of that community will help us to get good deals and to work on these aspects. This is a list of the services my colleagues and I brokered last year. I want to share this list because it shows vendors that are willing and able to work with us, and they might be able to work with you as well. We got some good names on there like IBM, Cisco, Google, Microsoft. On a list like this, it sounds easy, but I can tell you it was not easy at all to make these agreements. So gathering our strengths in Europe, working together as national research and education networks will really help us, and that is what we need to do. We need to work together. Anyone know this one? I think you do. If you say cloud, you say Patriot Act, right? There was questions surrounding it. We wanted answers in the Netherlands, and we asked the University of Amsterdam to investigate, and they wrote a great report, and it got even picked up by CBS News. And what they found out is that the Patriot Act gives American government agencies the opportunity to look at your data. And the Patriot Act applies to all American companies, but also to companies from elsewhere, from Europe, that do a substantial amount of business in the United States. In that case, the Patriot Act applies also. And the Patriot Act gives American government agencies the opportunity to look at data stored at servers in the US or elsewhere in the world. So a company saying, an American company saying, I'm gonna create a European cloud for you. It's very good for technical reasons, but the Patriot Act still applies. That doesn't mean that you can't use cloud services, but it means that you need to look at what type of services you put in what type of cloud. And in the Netherlands, we created a data classification, and all universities and research organizations are going to use this one. And it gives us certain thresholds and levels to agree with each other what type of services we put in public clouds and what type of services we will produce in community clouds. We will keep to ourselves. So we're definitely going to share this information and this report with you when it's available in the final version. We are currently finalizing it, and I will share it on the website. This might also be useful for you or for colleagues. I want to share this with you as well. We wrote a sourcing template which helps organizations decide which services can be brought outside and which are better in-house. So that template might be usable for you as well, and you can find it at this URL. What we also do in the Netherlands, we have a fixed set and certain phrases that we use in all our agreements, and I'm pretty confident that these are quite good and they adhere to European standards as well. It's up at this URL. Most is in Dutch, but we got the English phrases in there as well that we use to make agreements with cloud providers. And one important topic deals with auditing, that we want to make sure that we can audit cloud providers to be able to control how they process personally identifiable information. Because the Dutch Data Protection Agency made a statement saying that you are always responsible as a consuming organization for your personally identifiable information. And these contracts help to get the right agreements in place. The final thing I want to talk with you about is about cloud integration. If you use multiple clouds, you must string them together, right? You must make sure that they interoperate. And that is something that we are very good at as a research and education community. We are very good at authentication and authorization and making services, creating a middleware that allows you to log in with your trusted institutional account in a whole range of different cloud services. You got these in Sweden and Norway, and that is something that we will be working on again in Zeeland to make sure that cloud providers will adopt these standards as well. So to conclude, for me, my three main topics is that cloud services empower end users to use the services that they want and need, that cloud services disrupt the traditional supply chain, and to be able to prevent cloud fragmentation, we really must work together as a community to make sure we interconnect the clouds. Thank you very much.
Netherlands. I think we take questions later for the panel and when you sit down there so we can have a discussion. Now I give the floor to Ivan Porres, who is from Åbo Academy University, and he's been involved, among other things, in a Finnish research program, Industry Academy research program called the TIVIT Cloud Software Program. And this is also part of your research doing this, so please.
Thank you for the introduction and thank you for inviting me here. It's great being here and present you this project. I got the title of Nordic Opportunities for Cloud Software Collaboration, but I will focus on this cloud software program. The materials that I'm presenting here are based on a presentation from Janne Järvinen, that is the program director, so he should get credit for this. Cloud Software Program is a 4-year research program in Finland that has as focus to improve the competitiveness of the Finnish software industry. And it involves 29 different partners, including industry, IT industry, education and research organizations, universities, and also CSC, that is well represented in this conference. It's an industry-driven research program. That means that it's the industry that defines the research agenda and the research objectives, and we researchers, we have to work on the problems defined by the industry. And as I said, the focus of the program is to improve the competitiveness of the software industry in Finland. It's not a surprise, or it's not big news that the software industry is transitioning from a product-based industry to a service industry. And that means that IT organizations, they have to change the way that they are developing products and how are they delivering these products to the customers. So an important element of providing the services is over the internet is to have the capacity to handle many different users and to handle variations in the level of users. So for these organizations, it is really important to be able to host services in cloud infrastructures and take advantage of the elasticity that cloud infrastructures provide to them. The research program has three main work packages of three main components. The first one is cloud business, and is maybe the most important one, figuring out how to make money out of services deployed in the cloud. And this is especially important since many of these services, they have a freemium model where the service is offered almost for free or completely for free to users. So it's really important to figure out how to reduce costs and how to actually make money from something that you are offering for free. Another important component of the program is software processes and work processes. This transition from products to services means that now companies have the opportunity to release new versions of their services much more often. So they are moving from 1 to 3 year product development cycles to really short service iterations where new versions are delivered maybe every 2 months, 1 month, and sometimes even every week. So there's a need for these organizations, often large companies, to change the way that they work, adopt lean and agile approaches, and being able to listen to the customer, react to the customer, and offer new services based on the customer needs much more often. And then the third big work package is cloud technologies. So what are the new developments both at the infrastructure and application level that allow to implement in practice the visions and the business ideas created in the first work package. Of course, user experience, security, and sustainability are also important elements of this project. And maybe this is the first lesson or the first key message that I want to bring here to the presentation, is that this idea of combining three completely different aspects of software, the business models, processes, and technology in one single program actually has provided many benefits to all the involved organizations. So, for example, from a researcher point of view, I'm more interested in the technology. It's really interesting to work together with business people and listen to their business model, really understand their needs, and use these needs as drivers for research in software technology. The program is a 4-year program. We are in the last year of this program, but it's actually the planning and execution of the program is divided in yearly projects, and each project is divided in really short iterations. This was something that actually at the beginning I was not really happy about this. I mean, if you are a researcher, you know that it takes maybe 2-3 years to carry out good research from beginning to publication. But actually during this program, I learned that this works really well. It's really great to have these periodical meetings where everybody gets together, presents new ideas, discuss new ideas, show demonstrators, and gets feedback. And this three-month research cycle and idea development cycle works actually really well. So we meet 4 times per year in different places of Finland, and there we show our new ideas, demonstrate it, and get feedback from the companies. And it has been for me, one of the better insights of the project. This works really well. So if you are interested, we have the next meeting quite soon in the city of Oulu, where part of the program is open to the public. Besides these general meetings, we also organize workshops and even hackathons, where different people from different organizations sit together and maybe try to develop an idea in a kind of marathon style and try to come up with something together after working 24 hours or 48 hours in the same room. And the interesting thing here is that you get people from different universities, from different companies, working on the same idea and trying to create a demonstrator of one idea. And the spirit of this program is trying to work together and learn together and share experiences together. And I think it is actually working really well. So we are in the last year of the program, and there are many results to share, both at the business level and at the research level. So many large organizations at the size of F-Secure, Tieto, Ericsson, Nokia have carried out internal process transformations, and we researchers have been able to observe these transformations and report on these transformations, and actually the results are really good. It has been actually really interesting to see companies like Ericsson, where by just changing the way that they work, their working processes, they are able to develop new products much faster and with much higher quality than before. And these are the same people working on the same organization, developing the same type of software, just they are working in a more effective way and producing better results. The program has developed also several cloud service concepts. These are experimental services, usually used as demonstrators, but there are many interesting results that they can be shared and learn about this. So for example, I have been involved in this Budding. It's a collaborative software development. The idea is that you can create web applications using a simplified environment without the need of any special software development tools. So the only thing that you need is a web browser, and with this you can access all the development tools, create a simple web application, click a button and deploy it to a cloud. Everything without the need of installing tools and having a deep knowledge of how the underlying cloud infrastructure works. If you are more interested on research results, we have also quite a lot of interesting things. From the infrastructure point of view, there has been maybe less results because most of the organizations and companies are interested on applications and new services. But for example, there has been some work on energy efficiency, for example, how to reduce the energy consumption of servers simply by allocating tasks to different cores in a computing node. For example, we have observed that this has a small hit in performance, but actually leads to large improvements in energy consumption. There has been also some work on, for example, how to deploy and move virtual machines in a infrastructure more efficiently. At the application level, for example, some groups have been working on bioinformatic applications using Hadoop, MapReduce. So for example, this is something that maybe traditionally would have been done with high-performance computing technologies, and in this project we have been looking at how to do it with MapReduce and cloud infrastructures. We have been looking at elasticity prediction models and admission control algorithms for different kind of applications. So there has been a lot of research looking at these problems in a generic way. What we have been trying to look is what is knowledge of specific applications, such web applications, video encoding applications, or telecom applications can be used to optimize existing algorithms and allow these applications to run better use less resources in existing infrastructures. And also, as I said, there has been many works on how to improve development tools to create new cloud services faster and simpler. So, to summarize my presentation, if you are interested, you can find most of the results publicly available in our website. We have this website, cloudsoftware.org, and we have these regular meetings. Most of the meetings, they have a public component that everybody can attend. And the next meeting is 4th of June in the city of Oulu in Finland. And there will be a seminar on the future of software business that is open to the public. And the day before that seminar, there will be a meeting of the annual computer science event for Finland. So universities, researchers in computer science of Finland meet once a year and discuss advances in research and education in computer science. So that can be also quite interesting for you to attend. So to conclude my presentation, this is, I think, a research project creating many results interesting for those who are working with cloud software. The combination of business models, software processes, and cloud technology in the same project has led to many interesting results. Short iterations provide a lot of feedback to the researchers and again lead to better research results that fit better the niche of the industry, and also getting knowledge of specific applications into existing algorithms for cloud software can lead to improve results. So, and this more or less concludes my presentation, so thank you.
Thank you. Thank you very much for this presentation, and we come back to the questions in the panel. So now Vangelis Koukis from GRNet is putting on the gear so we can hear what you have to say.
Is it working?
Yeah,
it is.
I think so.
Okay.
Yes, welcome.
Hello.
And Vangelis will talk about how to deliver cloud services and a project and system developed by GRNet for this. Please.
So, my name is Vangelis Koukis. I work with GRNet. We're building a cloud service. It's called Okeanos. I'm here to talk to you about the service, the way we built it, the software behind it, and how this is meaningful to you as researchers or to you as people who want to bring researchers closer to using a cloud service. So, we were asked by the organizers, and that was a very good move to have 3 key messages in our talks. Well, my 3 take-home messages, which will be the main theme of the talk, are the first one. It's a fact. The NRNs have to provide cloud services to their users, and they need to do it yesterday. We have recognized, numerous talks, even in this conference, have recognized the need to bring higher education, researchers, students, professors closer to using a cloud service. How do we do it? Do we do brokering between third-party cloud providers? Do we resell virtual machines that we buy from outside entities, and that's it? Do we build our own solution, something homegrown? Do we bring the vendor into the data center and say, I want a turnkey solution for providing cloud services to my users? Do we use proprietary hardware, very big storage area networks and storage arrays? Do we use commodity hardware? How does that impact the kind of service that we are able to provide? When we do that, depending on our choices, where will the data of our users reside? How does this impact our service and our users? And finally, at the end of the day, how much will each VM cost? I have the answers at the end of the 3 facts I'm going to present, because that's what we actually decided to do, at least the answers that we believe are true. The second fact that was pretty painful to discover in building the service. To provide a public cloud service is a tough engineering job. It requires distinct skill sets. You need to be able to do both web-based things and low-level let's manage processes things. You need solid engineering. You need to work in many different layers, from the virtual machine, from the hypervisor, all the way to the API and the web interface, JavaScript. Completely different worlds. How do you do that? How do you find the people to do that? How do you build a team that can do that? How do you get the results of your effort into software that's usable by others? That's what we're trying to do. That's a spoiler for the next slides. So, that's the second fact. Third fact. People say that VMs are like cattle, they're like cows. You can leave them out in the field, they'll go eat their grass, and then they'll get back, and they'll give you milk. If one of the cows dies, who cares? I've got 9,000 cows. If one dies, okay, I got 8,999 cows, I'll buy a new one, I'll still have my milk. Well, it seems users don't actually see it that way. Sure, you can put all the way onto the users and say you have to write your application so it's elastic, so it is fault tolerant, so that it can survive VM failure. Fine, but how about having a cloud service that has robust VMs? How about having a cloud service that can actually withstand hardware failure? And how do you do that on commodity hardware? What does withstanding failure mean for a VM? It means being able to live migrate in case of hardware failure. How do you live migrate if you use commodity hardware? If you've got one node with disks here and another node with its own disks over there, how do you migrate? So these are all questions. These are all things that we believe are true. What we chose to do. We chose to build our own. We chose to build an Amazon Web Services-like public cloud service. We call it Okeanos. Okeanos is Greek for ocean, with all the happy connotations that this has. Now, we decided to own the engineering process. We decided to invest in building the know-how. We could have brought somebody and said, do it yourself. This is not going to work. Because you have to know enough to be able to control the process. You have to know enough to be able to have a product that actually fits your needs. There is no turnkey solution in building something like that. And at the end of the day, we want to drive innovation. We want to do something innovative. If all we do is buy from outside entities and resell things, how does this impact our ability to innovate? Whatever we would do would be open source. And our software, more on this later, Cinefo, is open source and you can download it right now. You can install it in your own data centers. The goal is production quality, infrastructure as a service, VMs which are persistent. You shut them down, then they're back, and they're still there, which are live migratable on commodity hardware for large-scale installations, hundreds, thousands of nodes. We've scaled. We'll talk about this later. And the user interface that is as simple as possible, so that we can bring novices to the cloud scene. We can bring them and have them use the service. Let's see. I'm not running out of time. So these are a few screenshots so that you can get an idea of what I'm talking about. This is the actual service running. This is the web interface. I want a machine. I can choose one of the images. Okay, I want an Ubuntu machine. These are 2 machines. I can control them. These are 2 machines on the public internet. I could have a private network as well. I could connect, disconnect, do whatever I want with my machines. We have this up and running. This is the storage service that accompanies the compute service. We have them very tightly integrated. I'll talk about it later. My files are also my images, the initial templates that I can use to make VMs from. Okay, so how do we do that? The initial decision to build a cloud service was taken in 2009. Design started in 2010. What were our options there then in terms of open source software? We had the first machine up and running in June or July 2011. The service has been running in production ever since. It's possible that one of the machines that we're running right now has survived from back then, from these days, because we've migrated the VMs that have brought them all the way to here. Numbers. We've got more than 3,500 users from the Greek academic and research community, students, researchers. We have more than 4,600 VMs that are currently active. We've spawned in the order of 50,000 VMs, 49,000 something. That's the current number of VMs that we have spawned, and they have died, and we have spawned more. We have 10 compute clusters in production, and that's how we scale. We are now able to scale linearly by adding uniform compute clusters in production. Every cluster is in the order of 20 nodes. This is a graph of the number of VMs since August 2011. It's a bit obsolete in the sense that I've only updated for last month, so we gained about 500 VMs in the last month. The software that we used to build the service, we call it Synefo. Synefo is Greek for cloud. That's not very original, but it sounds good. We chose to reuse existing software for that. We reuse Google Ganeti. Ganeti is a very fine piece of engineering that manages VMs at a low level. Synefo manages multiple Ganeti clusters. So we scale by adding more Ganeti clusters. We have a compute, a network, and a storage part. Everything is open source and available, and you can download it and so on. So more about the architecture of the software. The main point I will be focusing on, I won't get much into the technical details. We can talk about it afterwards if you'd like. I'd be very interested to do so. The main point to focus on is the distinction between the cluster and the cloud layer. These are the layers we recognized, from the hypervisor, the very process that creates the virtual machine, all the way up to the user interface. Now, there's a very thick line between the lower parts, the low-level, very difficult engineering, process management, logs, command queuing, migrations thing, and the higher-level APIs, web interfaces, JavaScript, Python, access lists, sharing part, the cloud part. Different skill sets, different people. So we chose different software for this. We don't want a single piece of software. I've chosen OpenStack in this case, but it's just an example because it's very well known. We don't want a single piece of software doing everything from the hypervisor, okay, from managing KVM anyway, all the way up to the user interface. We want a different piece of software, which was already there ever since 2006. They've made development ever since 2006. I'm sure they know better. They've been developing the software for 7 years now. So Ganeti manages the low-level part, and Synefo manages the higher part. So we're free to do agile development, as Ivan said. We were able to upgrade once every month, or even more frequently. Why? Because we had bugs. You always have bugs. You have a very fast-changing piece of software. It has bugs. But this never impacted the state of our VMs. Our VMs were there. Perhaps they weren't available for like 5 minutes. For control, they still were running under Ganeti. And we were able to start and upgrade and work with the software without impacting the viability of the VMs. We were able to upgrade Ganeti without upgrading Synefo as well. 2 different release cycles. Each one of them adjusted to the individual needs of the layer. A very fast-changing cloud layer versus a very slow-changing, very steady, low-level cluster layer. Moving on, this is the general architecture of the system. I'll just go through the slides pretty quickly. The technical details, we can talk about them as long as you want. Kyklades, the VM part, manages a number of Ganeti clusters. The clusters are available to the administrator. He or she can do whatever he or she wants with them. Pithos, the storage part, manages a number of RADOS or NFS or storage area networks or NAS devices or anything else. We've got drivers for that. The users come and use the APIs to talk to the system. We've chosen to standardize on the OpenStack APIs for third-party interoperability. We use the specification, not the actual code. So, the main features of the system. We have completely integrated compute and storage. We can spawn VMs from custom images, and the images are files in the storage part. The user syncs their files and their images along with their files, and then they can immediately spawn VMs from these images without copying the data, without any actual data movement. We've got a custom storage layer that allows for very fast VM creation while the VMs remain migratable. We can do 20 or 30 VM creates in like 2 minutes, and the VMs are migratable. They have distributed storage beneath them. One other interesting thing about interoperability that also Andres mentioned, we have multiple login methods in our identity system. We support Shibboleth-based logins. We support Google-based logins, as an example. We support Twitter-based logins, all of them behind a single interface to login drivers. We have per user, per resource quota support. We can change the limits for every individual user. There's a nice user interface for that as well. And what's also been accepted very well by the users, they can request projects for whatever they need. They say, I'd like 200 virtual CPUs for this or that. We accept them, then they can use them, and they can share the virtual CPUs they get. So we have a number of users who submit R&D project proposals, for example, and they use us as their infrastructure provider. Other things that we were able to do with software. Rolling hardware and software upgrades, no downtime for VMs. We evacuated nodes, then we can shut them down. We moved all the VMs from one data center to the other at the initial stages of the project. We moved them from Intel to AMD machines when we started buying new machines. Nobody actually understood that this was going on. Their VMs were always up and running. We renumbered all the VMs. You can scale as you go. You can install the software now, then you can start adding Ganeti machines, Ganeti clusters, as you buy new machines to meet demand. You can add IP networks as you, sorry for that. You can add new IP networks to meet demand for IPs, all distinct ranges. So, to summarize, try it out. We've got a trial. It's at cinefo.org. You can log in right now and create your own VMs and see how it works. See the production system, download it, install it in your own data centers, try it out. There is an external deployment right now going on at DAKE, the Danish Infrastructure Corporation. They have interconnected their own Cinefo deployment with Wave, so you can actually log in using Wave there. It works. It's very nice to see it work. It was very nice for us. That's all I want to say. Thank you for your time. And if there are questions.
Thank you. Very impressive work here. Thank you very much for this presentation. Now I come up here also, and I would like to invite Steven Newhouse and Salman Toor to the panel, so we get some more people here to discuss. And I have my prepared questions here, and I also expect the audience, so you can interrupt at any time and ask questions also. Now is the time to do that. We have microphones that are working, it looks so. There are green lights, and people are in place. So you have all got the chance here to present yourself. Stephen earlier this morning. But Salman, you are new here to the audience and to us. So could I give you please just to tell what you are doing? And
Hi, my name is Salman Toor, and I'm working in Helsinki Institute of Physics. and the task is that I'm working on to explore the upcoming open source cloud infrastructure for how we can maximum get benefit out of those. And we have started with the OpenStack together with, and basically the test case or the use case that we are using is the CMS analysis job. And we have successfully managed to deploy the OpenStack and together with the Gluster file system. And what we have, our architecture is something like that, that Gluster is used to run the instances. The instances are sitting in the Gluster file system, and also within the images, or actually within the instances, we have again have this GlusterFS to provide the shared area within the infrastructure. And the task is basically to use how much we can gain out of this Elastic solution compared to what currently we have in a production environment. And the production environment in the Helsinki Institute of Physics for the CMS jobs are based on Arc middleware. And within our cloud infrastructure, how we are publishing our resources is using Arc. So what we are, Arc is, I guess everybody is aware of that. That's the Advanced Resource Connector middleware. So what we are doing, basically, we are starting different virtual machines in the cloud and then putting the Arc middleware inside it and using the Arc interfaces to submit the jobs in our system. So this is the first level of things that we are doing, and second is that we have a collaboration with the computer science department, and they have developed some data indirection techniques based on the publish subscriber pattern, and we are thinking to use those techniques within the data center that we have to make it more resilient. So that's like a basic introduction for what I'm on it.
Okay, so one could say that you connect yesterday and today then with grids and clouds.
Yeah, it's basically, you can say it's a hybrid solution that we are getting the Elastic solution using the open source cloud infrastructures, and we are using the grid to getting the job so that the user end will not affect with whatever we have on the infrastructure side. So for the end user or the workflow models, it's totally transparent what we are running or how we are running in the data center.
Okay, thank you. So coming back to the questions, and I'm very impressed with all the presentations here, but honestly guys, services on the internet, yeah, why should I bother, and what is new with this? Why is this just marketing now, calling it cloud? Services on internet, I have seen this for a very long time. People trying to sell computing time commercially, tried before. I remember, I'm old enough and have remembered and even programmed the IBM mainframes, similar thing. So what is this about? Is it really something new?
I think it is, Per.
Okay, tell me why.
Yes, it's a good question. To me, the biggest difference is that users have choice. They can use your service, they can use Okeanos, and if they don't like what they have internally, they have alternatives, and they can grab their credit card and go to Amazon and use the services there. And that is, I think that is really disruptive, and that is a big change. We are in competition with these vendors, and we need to do better, and we need to provide added value. And I think what we've shown in the presentations, that we have some pretty good things that we can add to this, but there's work to be done.
Okay, Stephen.
I'd go beyond that. I think it's not only that the fact that there's a competition between different service offerings, but the service that's being offered is offering a level of flexibility and low-levelness that we haven't seen before. I mean, yes, you've been able to do software as a service by buying into an application. I mean, that is very much old hat. Going a couple of levels beneath that, that's pretty new, and certainly doing that and exposing your data center like that is quite a revolutionary concept.
Okay, I'm almost convinced. Okay, Mikael waved here for a question, yeah, or comment.
I've heard the magic word before, the credit card. And if you know, credit cards and researchers usually don't have one, or they need to ask for one, or use their own one. So aren't you developing an awful lot of new things where you could just instead give the researcher a credit card and let him use commercial services?
I'd like
Yeah,
to
please, Van
take a
Jones.
try and answer that. Well, what would the researcher use the credit card for? Go buy Amazon VMs. Okay, that's the main point, I guess. The NRNs have a very powerful weapon in their hands. It's a network. Why do we let the NRNs build the network? Why build academic networks? We have seen that the networks brought added value to researchers. Why not give a credit card to researchers and say, go buy your own networking? Because it did work much better. It has proven itself that it's much better to build academic networks and collaborations and all the good things that come with them. Well, it's the next thing to do. It's the logical extension of building an academic network. Build the compute power that's very closely connected to your own network. You've got your own dark fibers. Why not have your own VMs on this very network? Why not have VMs that the end user will be able to have them magically appear in their own address space? How can I have Amazon VMs appear in my university's address space? How can I have part of my network operations center's servers run on the cloud? GRNet or any other NRN can do that. We can actually here right now have the user's IP space. This does require a bit of manual configuration, a single command. We can actually do a layer 2 VPN, for example, and bring it right to the user interface and have them connect VMs to their own university data centers, this kind of thing. So one thing is we have added value. We have better functionality. The other thing is another speaker, I think Ian Fisk from the LHC, mentioned the car rental model. If your needs are above a certain threshold, it makes sense to build rather than buy. And at the end of the day, we also want to innovate. We also want to gain know-how. If we are to buy, what are we going to do? We're going to take the researcher, the credit card, European money, and use it to buy innovation created elsewhere. Do we have this kind of innovation? Are we able to build something similar? Do we have this kind of engineering? Why not invest this money to people? This is also a theme that arose during the day. Yeah. We need to build people networks, right? Sorry, I'm monopolizing time.
I will interrupt.
There's another space of innovation than the public one, and that's the private one. It doesn't have to happen in the US. So you could buy the service from a private vendor in Europe, and they could innovate and earn money.
Okay,
and
Stephen,
sell it to US.
Stephen want to comment on this, but we had a question from far back there that so I think belong to this subject. Maybe while we transport the microphone, Stephen can make a short comment.
I know Per likes controversy, so let me please enter into this. So I think it's an excellent question from Michael there. Do researchers build their own power plants to get electricity anymore? I believe not. So I think the arguments that's presented by the NRENs in that there's a need to provide these services in the academic sector has value, but on its own doesn't bear inspection. Where the academic sector, be it NRENs, be it EGI, has value, is in doing something that isn't available in the private sector. And the cost of using a 24/7 service in the private sector is certainly a lot higher than it would be in using it in the public sector. But also at the moment, the needs of the research communities in terms of using cloud aren't really focused around the infrastructure. It's much more about the added value services that go around that. If it was just around providing plain resources, then going to Amazon or European SME or whatever would certainly be an option. It's about the consultancy and about actually using the distributed system, which is where the NREN, EGI, and other places offer value. And until that is actually delivered effectively on a commercial private sector value, that's when the researcher perhaps should be issued with a credit card and to go off and spend it. So innovate, Michael, in that area.
Okay. Now, is the microphone there in back now? Yes.
Yes, it is. So I found it very interesting that you're focusing so much on the competition between the different cloud vendors, while at the same time standardization for interfaces, both for the computing and for the data part, is going rather slow. And why should it go any faster? Because it's not necessarily in the interest of the vendors. Now, I think Andreas mentioned that the solution that you're pursuing is to add a layer on top of the cloud. You're adding a middleware layer that can do brokering, that can do authentication. Well, to me, that sounds like something we have been doing for quite a while. That's called Grid. That's the core difference to me between grids and clouds, is that all this stuff you don't have in clouds. That's why clouds are so simple. It's single vendor, it's self-provisioned, it's simple interfaces, because you don't have all those cross-vendor issues. So if we suddenly start wanting to have this competition, this free market between the different cloud vendors, aren't we bound to reinvent all the complexity of Grid?
The layer that I mentioned has much to do with authentication, is to make sure that we get controlled access, that you can log in with your trusted institutional account to all these different clouds. If we want competition, we must be able to use services from multiple vendors. Only then will they compete with each other. But using multiple services from multiple vendors is very difficult if you get a different login account at each and every vendor. And we have the technology in place. We've been doing this for years as a community on a middleware level that allows us, Vangelis mentioned this as well, the Shibboleth part, for example, to log in with that single account into all these different vendors.
May I add something to that? So what you're saying is, you don't want a single control mechanism for all clouds. You don't want a single command queuing mechanism, job queuing mechanism for all clouds, because that's what the
that is what Grid does.
person who asked the question actually, I think, means. This would bring the grid back into the cloud. I don't think we want that. I think this may be part of what's actually happening. I think nobody really wants that. Nobody wants the complexities of old days brought back into the self-provisioned infrastructure as a service. I have my own machine, I'll do whatever I want with the world. This was all with hyphens. So we need a common authentication layer. This is what Andreas is talking about, I guess. But we don't need the same old grid-based command queuing things, let's run grid middleware in cloud VMs and so on thing. I think we don't need that. But we need the common authentication layer.
Okay. Do the audience agree what we need and don't need? Yeah, does someone want to comment there?
Do you agree if you put your hand, or did you disagree? I'm curious.
Yeah, here's my agree, yeah, okay.
So there was the question was specifically about standards, or one part of the question was about standards. And there are cloud standards out there. The issue around the big vendors adopting them is what they're always doing, is they're refusing to adopt them, because that would then remove the lock-in that they have around their particular customer base. The federated cloud activities that UGI is driving is very much about standards-based activities and taking the standards that are available, using the implementations, and then providing feedback to the standards organizations around them. But unfortunately, like all good standards, there are so many to choose from that this is one of the barriers that we have to deal with.
I think that is why we're here, right? To decide which standards we want to use as a community. And if we say as a community, we go for these type of standards, that will certainly help. So having a common language is very important here, to choose as a community what we want to pursue and which standards we find are important to us.
One question in the back there, and then we have a guy here in the front.
You're talking about clouds, and you're talking about developing clouds for kind of maybe a limited market, to put it that way. Isn't there a risk that the whole user base would need the peak at the same time? How do you plan to cope with that problem?
Boltzmann.
The benefit of Amazon and Google is that they have a very broad user base. People might not necessarily need all their resources at the same time, but in the research community, you might risk that everyone needs everything at the same time. How do you plan to cope with that problem?
Okay, is this solved by thermodynamics, as I implied, that the chance that all oxygen molecules in this room goes down in that corner, it is there, but will it happen?
So I'm going to steal an answer that my colleague David Wallum gave from the UK about 6 months ago. Well, if you're paying for those resources, then that's great. You come along, if you decide that you want to block out every single core in the academic cloud for the next 6 months, good, but expect either you, your university, your research funding council to get some sort of bill around that. If you do, and if we do run out of demand, then we can do what every other provider does, and that's potentially scale out to a commercial cloud provider, because that's where ultimately some of the extra resources are. You know, the key thing about federating cloud resources is it gives you that uniform level of access into different resource providers, and makes scaling out a lot easier.
Okay, we had a question in here
Thank
too.
you. First, I would like to congratulate you all for your innovative efforts. My question is, when you're in innovation, how much are you willing to share your experience with each of you, so that the user get a better product? Like, it would be more comfortable than, for instance, Google and Apple or Amazon would share their knowledge.
What we want to achieve in GÉANT, our European collaboration, is exactly that. And I think it's about sharing failures, because we can all give a success story, but the real lessons learned are in the failures. So that is what we are currently doing in GÉANT, is talking to each other and say what went wrong and what do we need to improve. And I think it's one of the main advantages that we have in our community is the willingness to share compared to the commercial world. And that is one of our assets, the willingness to share not only the good things but also the bad things. Let's do that.
Maybe
Let's
Ivan
share
have
our
something.
failures.
Maybe Ivan have something to add this, because you have companies that want to share also.
Yeah,
maybe.
I want to share my. So from the point of view of researchers, I mean, it's publish or perish. So we researchers, we want to publish all the time. From the point of view of companies, then there's this incentive of public funding. So at least in Finland, if companies do not want to share any results, they have to fund the research 100% privately. If they want to obtain public funding, they have to share results in the consortium, some results, and in the public in general, other results. So that's a good motivator for private companies to maybe decide to share some results. And it happens.
Yeah. Vangelis?
We are already sharing everything. I mean, Andre said, share your failure stories. We're sharing our failure stories through our Git commit logs. You can actually see the commits that fixed bugs. We started with 100 VMs, and then at some point in time, the system had a problem, a scalability problem, so it failed for a day. No, didn't fail for a day. It was, let's say, degraded performance for a day. So we fixed it. You can actually go see the commit log and say, we had a scalability problem, it was this or that, we fixed it. You can download the software and get the condensed result of our fixing our failure stories in a single tarball or a single Debian package. That's it.
Yeah. And I think this is a very good example. I mean, it shows also that this openness, it helps you, I guess, to make trust with the community that are interested in your products.
It was a set goal that we needed users, because they click all the time, and when they click all the time, they expose bugs all the time. And they expose bugs, we get to fix them.
Okay, we had a
and what Stephen said earlier on about consultancy, about helping each other, I think that relates to that as well. to not getting the salespeople in to help you, but actual people that know their stuff, that talk about the tarballs and everything, that know clouds and that know what you guys are doing. And that is working together in a community.
We had another question in the back.
Yeah, I have another question regarding standards, and maybe this is for Stephen Newhouse. So back in WSOG, some years ago, and I'm mentioning this because the whole theme of the conference is lessons learned. There was a need identified to standardize interfaces for storage resources. And a lot of work went into inventing something called the Storage Resource Management Interface. That I think is generally considered a huge failure. Now in the cloud world, there is a need for standardizing interfaces to data stores, cloud data. And there's an interface called Cloud Data Management Interface. How do we avoid making the same mistakes that we did before? Because if you look at the CDMI interface, it looks awfully similar to the SRM interface. Slightly newer technologies, but pretty much the same kind of operations.
So SRM was something that came out of the HEP community and the need to rationalize the 6 or 7 different storage solutions that the HEP community had decided to that it had to have. The reasons why it was so difficult for that community to define what the interface was and then to implement it is not clear to me. I think part of it was that they had implementations and they were trying to then converge on a standardized implementation around that. And this illustrates the issue with standards is, do you standardize too early and you haven't got the experience that that standard is the right one, or do you standardize too late and then you spend all your time trying to get everyone to say, my API is the best API and that's the one we must use, okay? I think what you have to do is to have a standardization mechanism that is lightweight enough to deal with failure, because you're not going to get it right first time. And both the EGI is using the OCCI specification that comes out of the OGF, and we're also using the CDMI interface that you mentioned that came out of DMTF. And there's other ones around there as well that are also touching on both from the broader distributed computing community and from the grid and other communities. If they don't work, then we'll find out. But what we're doing is we're engaging in the open process to see if they do work. And if they don't, then there's an open process for identifying and documenting that and feeding that experience through into future revisions. It's community building.
I would put a question to Salman before, because you are developing for a user community here then. So what is the role of standards in this respect? How important is it?
Actually, for us, the reason why we have chosen the already available middleware is that we know that we cannot convince or we cannot force our end users to start using another interface that is totally new to submit their jobs. That is not acceptable for them. So what we have done, we have tried to make our efforts maximum on the infrastructure side to make it elastic, more resilient, and better management in lot of sense in terms of computing and storage. But we try to minimize, or actually we have tried to minimize as much as possible to put the load on the client side. So that's I think the only way we can go forward to make the learning curve less for the end users and putting the facilities in the infrastructure as much as possible. Yeah.
May I
Yeah, please.
Yes, but at the end, if I understand correctly, you are exposing an ARC interface to your users.
Yes.
You're not exposing a Nova API interface, for example. You're not exposing an OpenStack API interface to your users.
Because my community to whom I'm addressing
Exactly.
the CMS.
The thing is,
yeah.
and this goes also to the CDMI controversy before, the HEP community, they're very good researchers. They produce very good scientific results. But how good are they in designing APIs? the open process is good, but there is a very nice way of finding out which API is good. It's the one who obliterates the market. There is an API in storage that has obliterated the market. It's the S3 API, right? Everybody knows the S3 API. There's another API that's going to do the same because it's got all the hype behind it. It's the OpenStack Storage API. If everybody else is using these APIs, shouldn't we give thought to the process of moving the users, no matter how reluctant they may be, help them with that?
Yeah, but
move to a,
yes, at some extent I agree with you, but the problem is that if I just come up with a new solution at a very beginning and say that, okay, this is my solution and accept everybody to my solution, and I'm a small site in a big community, it's difficult. Actually, they have, in CMS, they have a glide-in that allows to send the VM request. But we haven't accepted that because then we are totally restricted to the HAP community. With Arc middleware, we can have a runtime environments and we can allow multiple end users coming from different communities to use our infrastructure as it is without seeing anything.
My point.
So now the audience are very interested to participate in this battle. So I think I saw Leif Nixon back there. Matthias. Oh, it was Matthias. Yes. I need to have new glasses.
Okay. So I was just going to reflect that there are at least 2 protocols or interfaces off the top of my head that totally obliterates S3. That would be HTTP and POSIX.
S3, I'm not sure S3 is an HTTP API, but the OpenStack Storage API is an HTTP API. And POSIX, it's great, but it doesn't scale the way a distributed storage API does. That's why you can't use a cluster file system if you want really distributed big storage. POSIX is great,
I'm still saying that these are much, much bigger.
I know, but the OpenStack Storage API, it's an HTTP API, so we agree. I don't think we disagree here. You do an HTTP request, you get your object back. That's it.
So I'm going to
Stephen.
I'm going to totally disagree. So I'm going to totally try and switch this back on again. So I think we're getting incredibly entertained and interested in a discussion that is of no interest to any end user. Okay? What an end user is interested in, and to a certain extent this is what you're doing, is the environment they want to use. Okay? Be it Arc, which may have wonderful features or it may not, be it POSIX, which has its own issues or whatever it is. What they want is something that fits with the way they are working. Okay? What we're, I think, going to see with the move towards cloud is the notion of intermediaries. Okay? This is something in many ways that the WLCG team at CERN do. They are the interface between the infrastructure from EGI and OSG and the experiments. Okay? The same way that you have somebody who's going to use an infrastructure as a service mechanism to launch the set of virtual machines that a life scientist is going to want to use, and that life scientist will use something without knowing about S3, OCCI, POSIX, etc., 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 or even HTTP. And it's that flexibility that the intermediary can bring to this use of infrastructure, which is where, bluntly, private sector and also public sector opportunities now exist. And that's where we should be directing our energies and our enthusiasm.
Okay, so flexibility for the users, that's the message here. Sterker, I think it is.
Yes, I just want to say, the first part of what I was going to say, Stephen already said that, so I think it's very important. There is a voice missing up there, I think. That's the voice of the users. And I think what will happen in the future is also that we more and more see that the users actually sit with the money and they pay for the resources themselves, the communities, maybe not in the form of a credit card, but in form of research grants. And then it becomes very important that what is delivered is what the users want. And if the interfaces are bad from a computer science perspective, maybe so. But still, something has to be delivered according to the wishes of the users.
I'm afraid I may have insulted the user community by mentioning
Yeah, but come on.
users
it's-
designing it. Yes, that's not my point.
So we have one question down there, and then I want to switch gear a bit before we have to conclude the session here. We take a final comment on this topic.
Yes, I would like to follow up also and support also this comment about the users, and also comment a bit about the grid middleware. I think it's time that we indeed start focusing on users and start realizing that, as we have discussed this whole session, try to find out what our role is. If we as Envans, many of us, want to keep a role in this, I think Michael's point about the credit card is also very valid. We need to find a new place to put ourselves between infrastructure and the users. And I think, at least in Denmark in the old days, there were more so-called application experts in the Envans. I think that's something to reflect about. And it's not completely true that we don't have users in the board. We have exactly users represented on the very right there. It's just that we also have to stop talking about this specific user, because it is a very small fraction of the reality. And regarding the ARC middleware, it's a wonderful piece of engineering, but the last decade has shown that it is not what users want. So we should take this opportunity to try and find out what users actually want, and build that, be innovative, and and stop caring about whether we run it on Google or Amazon or anywhere else. I don't think we can compete with these things anyway. We need to provide the added value, as Stephen Newhouse says.
Okay, thank you. Yeah, I think this was also mentioned in Stephen's talk, that one suit doesn't fit all. That's Salman, a final comment here, that you have to defend yourself, maybe. That
Actually,
you're a user
I just want to specify two things. It's not only about the end user who what they want. It's also about what administrator who is gonna manage the whole data center, how they can be facilitated with this with these technologies, because it's really not very easy or you can say convenient to handle the whole data center by using something without standards or something that is not very scalable solution. So it's also like to make the facility at the people who are working in the data center. I think this technology can have that power to facilitate administrators as well. And also there are some components that need to be redefined when it comes to the cloud infrastructure. For example, the information system. In cloud, we are not basically publishing the resources. In cloud, we are publishing the capabilities. The method or the way we are currently publishing things in the clouds are basically we are publishing the resources. But there we are clearly missing some type of level of abstraction that is required to make the resources acceptable for the capabilities. So something like that.
Okay, thank you. So I said I want to switch gear, and we have 1 minute before we should end, but maybe take. And it was actually something Ivan brought up here. And you see where the companies connected, the companies that were working with cloud technology here in this research program in Finland, they were connecting lean and agile working methods with the cloud. And you mentioned here that it was a bit of a new thing or revelation as a researcher to work in this way, in a very short. For any software developer, this is common method now, and to be working in very short sprints and things like this. But this whole area of lean and agile, is there anything, and this is a question to the audience here also, is that what can we learn from that in the research process and connect it to the services in the grid, as they do in industry? Probably, apparently something to think about. And
yes.
There was a, I missed that, who is waving here? Ah, down there, sorry, there.
Yes, I think we could learn a lot from it, not only because of these short sprints that help us deliver a product very frequently, but also the philosophy of interacting a lot with the user, and also with all the interacting within the team, the Agile team. And I think that's going to help in this environment.
Agree? Agree. Yes. It maybe it's a too obvious thing to and too good thing, but I think the conclusion is that there is a lot of different things available here on the commercial side, on the public cloud sides, what we are providing on the public side and from the academic computing center can be combined with the commercial offerings, and we will see more of that in the future, of course. And also the way of working. I think this is really what will also be affected, and I think this is also a conclusion. The way how we can work and do research and be more productive and bring more quality also into our research. And I hope you have enjoyed this session. And I would like to again thank our distinguished panelists and speakers for your coming here and giving us some insight in this subject. Thank you.
Thank you.